In this video, I want to have a look at finding the area of different quadrilaterals. So we're already pretty familiar with finding the area of a rectangle and a square, but I wanted to have a look at some of these other ones. So this here is what I call our family tree of quadrilaterals. So any four-sided shape is called a quadrilateral, and depending on what it is, they have different properties and we can use different rules to find their areas. So coming straight down from quadrilateral, we have trapeziums. So a trapezium is a quadrilateral. It has one pair of parallel sides. If it has two pairs of parallel sides, then it becomes a parallelogram. So what that means is that all parallelograms are just special types of trapeziums, but a lot of trapeziums won't be parallelograms. We can also say then that if a parallelogram has right angles, then it's going to be a rectangle. If a parallelogram has all four of its sides equal in length, then it's going to be a rhombus. And if it has both of those things true, then it's going to be a square. We also have kites hanging off to the side here. So the properties of a kite are that it's got two pairs of adjacent sides equal in length. So you can see these ones here are the same length and these ones are the same length as well. And a rhombus is a special type of kite. So anytime you have a rhombus, you could also call that rhombus a special type of parallelogram, a trapezium, and a kite. And a square technically falls into all of those other categories as well. It's just more specific. All right, so what we're going to have a look at today is finding the areas of trapeziums, parallelograms, and kites. And then for a rhombus, you can either use the formula for a parallelogram or a kite, depending on the information that's given to you. So here we have a picture of a parallelogram. And we can change the shape of our parallelogram if we want to. But what we've got drawn on there are B is our base length and H is the height. So it's really important when we're talking about parallelograms that the height we're talking about is the perpendicular height, not the length of this slanted side here. So the height and the base have to meet at right angles. To find the area of a parallelogram, we can imagine cutting it down this dotted line here, and then sliding that triangle all the way across over to this side, and you can see that it makes a perfect rectangle. And that rectangle has a base of B and a height of H. So to find the area of this rectangle, we just do base times height, but the area of that rectangle is going to be exactly the same as the area of the parallelogram we had. So to find the area of this parallelogram, we are just going to do base times height. The next shape I want to have a look at is a kite. So here we've got a kite. I'm going to split it. I'm going to draw in its diagonals, so straight down from one corner to the other and from one corner to the opposite. Now what I'm going to do is I'm going to take each of these triangles, I'm going to duplicate them and rearrange them. So watching that, I'm making all of those triangles and cutting them out, and I'm going to put them over here. So you can see that this triangle is the same as this one, this one, this one, this triangle is the same as this one, and this one is repeated here. So what that means is that this kite has half the area of that whole rectangle because we've doubled everything to make this whole rectangle. So to find the area of that rectangle, we would do the length of this diagonal, which was D2, times by the length of this diagonal, which was D1. But that would be the whole rectangle, and we only want the kite. So we'd have to do a half times that diagonal times this diagonal. So the last one we have is a trapezium, and this is probably the trickiest one to visualize and understand where the formula comes from. So what we have is a trapezium drawn. The length of this bottom side here, the base, is labeled B2, and the length of this side here is B1. So B1 and B2 are our parallel sides, and we have the perpendicular height between those sides labeled as H. Now what I'm going to do is I'm going to duplicate this trapezium, and I'm going to rotate it and sit it over here. So duplicating it and rotating it so it sits next to it. So this trapezium here is exactly the same size as this one here. Now if we wanted to find the area of this shape, we should be able to recognize that that whole shape now is a parallelogram. And we know that to find the area of a parallelogram, we're going to go the base times the height. So in this one, we would do B1 plus B2. We'd have that in brackets, and then we'd multiply that by H. And that would give us the area of this whole shape, but we only want half of that. So we're going to do a half times H times B1 plus B2. So to summarize that, I've written them on here, but these formulas look a little bit different because I've used different letters. So for our trapezium, instead of doing a half times h, I've done h over 2. And I've used A and B as the lengths of these two parallel sides. For my parallelogram, I've got the base times the perpendicular height. And for my kite, I've got half times x, y. Now, x and y, they're standing for the lengths of the diagonals. So not the lengths of the sides, but the lengths of the diagonals in there. So let's have a look at a few examples. So our first problem is just asking us to find the area of this parallelogram. So we know the area of a parallelogram is the base times the height. So we're going to do 14 times 9, which would give me 126 meters squared. Our second example is a kite. So it's telling us that the length of this diagonal along here is 9 meters, and this diagonal along here is 14 meters. So the area of a kite is a half times one of the diagonals, so 9, times the other diagonal, so 14. And if we pop that in our calculator, that'll give us 63 meters squared for our area. For our last example, I wanted to come back to this shape here, which we actually looked at in our last video on composite shapes. So when we looked at it last time, we actually broke this down into a rectangle and a triangle. But now that we know the formula for the area of a trapezium, we're going to do that instead. So in this trapezium, our parallel sides are our 18 and our 38, and our height is the distance between them, which is our 15. So our area is h over 2 outside of a plus b. Our h is 15, so we're going to have 15 over 2 outside of 18 plus 38. And it doesn't matter which way round we write those, because when we're adding, the order doesn't matter. And if we put that in our calculator, we would end up with 420 centimeters squared as our area. Now, just a reminder again, if you do get a question that's a rhombus, you can solve it like a parallelogram or like a kite, depending on the information that's given to you. So if you're given the base and the height, you'd solve it like a parallelogram. But if you're told the lengths of the diagonals, you'd solve it as if it was a kite.